All right, here is the key to your Unit 1A assessment, or what I call like your AP style assessment. Remember that the grade on this test cannot hurt you. It will only help you because I will use the points that you get from this as bonus points on your test grades, which means it could still improve your first 6 weeks test grades. So we definitely want to take this seriously. It's just more in the actual style of AP instead of what our classroom tests are when I'm just trying to get, content from you. All right, so let's look at this one. At time t equals 0, water begins pouring into an empty vase at a constant rate. So we did this before we really did any lessons at all, talking about the vases, right? And so we are looking for the graph models the depth of the water of the vase over time. Okay, so the water's pouring in at a constant rate. Just think about turning on the faucet. So if the graph is always increasing at a constant rate, then the vase has to be a cylinder because your height is just going to increase at a constant rate because there's no change in the size of your graph. So this is graph 1. Okay, well, I guess that's not a real way to roll. Graph 1. Okay, the graph is always increasing. Okay, so they really should all be always increasing because we're not losing any water. The first half of the graph is concave up and the second half is concave down. So let's think about our fun chart. All right, so if my function is concave up, the rate is increasing. So the height would be increasing at an increasing rate. So remember, height is always increasing, but an increasing rate. Well, what's going to make the water fill up at a quicker rate is when the vase is going to get skinnier, right? So if I look at C here, as my water starts to fill up, the rate at which the height is changing should get quicker here, right? So my rate is increasing here, and then my rate is decreasing here because it's going to get wider. So if the rate is increasing, the first part is concave up, second part is concave down, and that's what this says right here. So this is graph 2. All right. Then the graph, again, is always increasing. That's true for all of them, right? The first half of the graph is concave down, and the second half is concave up. So if we're concave down, then concave up, that means my rate is decreasing and then increasing. The rate is going to decrease as the vase gets wider. So it's going to slow down because we have more water to fill up. So that's a decreasing rate. And then it's going to get quicker, increasing rate. So this is concave down, then concave up, which is graph 3, which hopefully means that this is graph 4. There are 4 portions, and we can see the 4 portions right here. It's where our concavity would change, and it's really actually even where the concavity of the vase changes, but don't get that too much in your head there. So I can see here, this is going to be an increasing rate because it gets skinnier. Then since it gets wider, that's going to be a decreasing rate. Then again, an increasing and then a decreasing. So that means we're concave up, then down, then up, then down. Then that's what this says. Up, then down, then up, then down. And this is vase or graph 4. Okay, there are your vases. Okie dokie. We are looking for, the figure shows the graph of the function g. Okay, so this is function g. So this is g of x. And we're going from -4 to 4. That's an important thing to pay attention to. So so I'm not going to the infinities or anything like that. The endpoints in the interval are labeled a and g, so it's telling me these are the endpoints. It's also something I can just see. 2 other extrema for g are labeled. So my extrema are my max and mins. It says 2 other, the max and mins, but there's actually 3 points. So here, here, and here. Points C and E are the only points of the graph well, only points of inflection. So here are my points of inflection. Points of inflection is where we have a change in concavity. All right, so we're going to let T sub A, T sub B, T sub C, E, F represent the x coordinates for those points. On what intervals is the rate of change of G ... Okay, so here's my fun chart, because we're talking about rate of change. Okay, if my rate of change is positive and increasing, if my rate is positive and increasing, that means that the function is concave up and increasing. So that's what I'm looking for in my function. Rate of change is increasing and positive, function is concave up and increasing. So write those little things down for yourself so we don't lose what's going on here. So we're concave up, this is concave up from here to here, but this is concave up and increasing, and this is concave up and increasing. So this would be T sub B, comma, T sub C, because these are our x values, and then T sub F to T sub G, and all of that is open, okay? If we are looking for positive and decreasing, that's, we're talking again, rate of change, positive and decreasing, that would mean the function is concave down and increasing, concave down and increasing. So the function's concave down from here to here, concave down and increasing right there. So that's T sub C to T sub D. Alrighty, then we have negative and increasing. If the rate of change is negative and increasing, the function is concave up and decreasing. So concave up and decreasing would be here and here. So that is T sub A to T sub B, and then T sub E to T sub F. All right, and then rate of change, negative and decreasing. Negative and decreasing would be concave down and decreasing, concave down and decreasing. That would be right here, T sub D to T sub E. Okay, there is page 1. Okie dokie, page 2. Determine if the following functions could be concave up, concave down, or neither. So again, this has to do with my fun chart. All right, so when I'm looking at concavity, concave up or down has to do with the rate of change being increasing or decreasing. So I first have to look at my input intervals. 0 minus a negative 3 is 3. This is 3, 3, 3. I have equal length input value intervals, all right? That means when I look at my differences for f of x, that basically represents the rate of change. It may not be the exact number, but I can tell what's happening with it. Excuse me. But some of you are having issues adding and subtracting your positive and negative integers, and this is getting you to have wrong answers. So I have to do negative 3 minus a negative 10 is going to be a positive 7. 2 minus a negative 3 is 5. 4 minus 2 is 2. 5 minus 4 is 1. I don't have to figure out if this is quadratic or linear, because it may be neither one of them, and still I can answer the question, because that question, that's not what it's asking me. All I'm looking at is, is my rate of change increasing or decreasing? So when I look at this, as my x values increase, my rate of change is decreasing. Since my rate of change is decreasing, my function is concave down, okay? So so I can put, let me just put concave down, all right? Then I can say rates, average, sorry. Average rate of change of F is, oh, actually, before I say is, sorry, average rate of change of F over consecutive equal length input value intervals is decreasing. That's why it's concave down, right? So then I look at B. These are all 10. -2 minus 0 is -2. -4 minus a -2 is -2. -8 minus a -4 is -4. -16 minus a -8 is -8. So this one would be neither. Okay. Then I can say average rates of change of G over consecutive equal length input value intervals are not increasing or decreasing. Sorry, I'm trying to not write over the decreasing, and meaning that just not strictly increasing or decreasing, because right there it's constant. I know that these then it decreases, but over this whole thing, it's not either concave up or concave down, as in general for the whole piece. All right. Okay. Then here, these differences are all 1. So I do have equal length input value intervals. 32 minus 64, -32. 16 minus 32, -16. And this is -8, -4. So my rates of change are increasing. So that means that this would be concave up. And then my reason is average rates of change of, what's his name, H over consecutive equal length input value intervals intervals are increasing. So the increasing goes with the up. All of that is from the fun chart. Okie dokie. So let's look at what all this says. So the figure above. Now words are important here. First of all, this is f of x. Determine the key features at each label point. Word bank below. If the point is a 0, determine the multiplicity. Some points could be more than one key feature. So here's what I get to choose from. 0, point of inflection, relative maximum, relative minimum, absolute maximum, absolute minimum. This should have an E on it. All righty. So point A. Point A is right here. That is a relative maximum. Relative maximum. All right. Then B, right here, that is where we are changing from concave down to concave up. So that's our change of concavity. That makes that a point of inflection. right. Then C, this point right here, that is going to be a relative minimum. Now I'm going to do G, H, and J because I can do those without scrolling, and then we'll look at the rest. G is right here. Again, that's where we change concavity, concave down to concave up. So that is a point of inflection. Then H, right? H, that is not a relative maximum or minimum because those happen, like here where I had a relative minimum, I was changing from decreasing to increasing. Here, I'm decreasing the whole time, right? But I'm changing from concave up to concave down. So H is also a point of inflection. All right. Then J, right here. Look at that, concave down to concave up. That is also a point of inflection. All right. So now let's look at, I have to scroll, I guess. I'm assuming the next one is D, right? So D right here. Look, we are changing from concave up to concave down. So that is a point of inflection. All right. Then E. E is right here. That's not my point of inflection, but that is where we cross the x-axis. And oh, look what I missed on A. It's also where we cross the x-axis. So A is also a 0, and I missed that. E is a 0. And with the zeros, I was supposed to figure out the multiplicity. So here, because I am bouncing, and it says my multiplicity would be 1, 2, or 3. So really all I know is that it's even, but since those are my only options, this would have to be a multiplicity of 2. And for E, because we just go straight through it, that is multiplicity of 1. And look, I missed the other 0. Goodness, I missed them all. Right here at H, that's a 0. That's a point of inflection, but it's also a 0. And I'm going to go up sideways like this. And because it is a point of inflection, that means it's odd but greater than 1. So this, in this case, it would have to be 3. Okay. All right. Then let's see, what letter am I on since I got all off here? F. So for F, I'm right here. That is a relative maximum. All right. Then K would be my next one. K is right here. That is a relative minimum. Right, then L. L is right here. L is a 0. It's not a point of inflection because I'm concave up this whole time. And I just passed through kind of boringly, so it's just a 0 with a multiplicity of 1. And then I have M. M is a maximum. Now it is a, so I know it's a relative maximum. but it is also the highest maximum. Okay, it's the largest of all the maximums. So it is also an absolute maximum. So if we go back and look at our smallest relative minimum, that was right here. That was C, but it's not an absolute minimum because this keeps going down to infinity. Okay, there's page 2. Page 3. So I've got to match the polynomial to the graph, right? And how many distinct zeros and things like that that I'm looking for. So when I look at this one, let's talk about in behavior first. My leading coefficient is positive, so the right side is up, and the degree, so this would be x cubed times x squared times x, so that would be 6, that would be even. Left-hand side is up, so it has to be up, up. That either makes it A or it makes it D, okay? Got to be one of those two. So then I have to look at what's happening with my zeros. At 0, I just pass through boringly. Boom, like that. At -2, it is squared, so at -2, I should be bouncing. Not bouncing on that one. So let's look over here. At 0, I pass through boringly. At -2, I am bouncing, which means I am tangent to the axis. I like all that so far. At +3, I have a 0, and that exponent is 3, so I should have a point of inflection. So I think D looks good for this first one. Okay. All right, so then when I look at h of x, so let me label this one as, this is f of x. And maybe it'll match another one too. Let's see. Leading coefficient is negative, right side is down. Then I have 3, 4, 5, 6. So left side is the same. So I'm looking for down, down, which is either B or C. Once again, at 0, I just pass through boringly. At -2, I should be tangent to the axis. And then at 3, I should have a point of inflection. So I like this for B. That would make this h of x. All right, g of x. Leading coefficient is positive, and this is 3, 4, 5, 6, so the left-hand side is the same. I pass through boring, so it's going to have to be, should be A, because it's the only one that I have left that's up, up, but let's check this. At 0, I pass through just boringly. At 2, I have I'm tangent. At -3, I have a point of inflection. So I do like this one to be g of x. So that would be A, which hopefully means that the next one is C, but let's check it. Leading coefficient is negative, right-hand side is down. 3, 4, 5, 6, so the left side is the same. So down, down. So it would have to be this one or this one. At 0, I just pass through boringly. At +2, I'm tangent. At -3, I have a point of inflection. So I like this. Also want to talk about some terminology that could happen here. Even though these are all 6th degree polynomials, the degree is 6, okay? I have 3 distinct real zeros. That means I hit the x-axis at 3 distinct points. So I do have what we would call a double root or a triple root, but I only count them once. So I have 3 distinct zeros because of the way that this works out. Okay. All right, let's look at 6. This says to complete the left side of each graph to make the symmetry be true. So even, if the function is even, then f of x equals f of -x. So this point here, which is at 1, 1, this point is at 2, 3, this point is at 3, 1, and this point is at -2. Nope, it's not. It's at 4, -2. Sorry about that. 4, -2, and this point is at 5, 4. All right, so if it's even, we are symmetric with the x-axis. So if I have 1, 1, then I also have negative 1, 1. If I have 2, 3, I also have negative 2, 3. 3, 1, I have negative 3, 1. 4, negative 2, I have negative 4, negative 2. 5, 4, I have negative 5, 4. And then I'm just going to do my best to model that. Oof. And then here's where I wiggle a little bit, something like that. Okay. This function is odd. That means f of x equals negative f of x. So once again, I have 1, 1, 2, 3, 3, 1, 4, negative 2, and 5, 4. Oh, 5 negative, that should be negative 4. 5, negative 4. And another way to look at these is with the mapping. So here for the even, xy maps to negative xy. For odd, xy maps to negative x, negative y. So I'm changing the sign on both of them, which means this would become negative 1, negative 1. This would become negative 2, negative 3. Negative 3, negative 1. Negative 4, positive 2. And negative 5, positive 4. Because then this should have, excuse me, we should have rotational symmetry here. So it looks something like that. Good enough. Nobody's going to make you actually draw it. You just have to recognize it when you do the others. All right. Yeah, that looks right. All right, so we're going to describe the end behavior left and right of each of the following using limit statements. Okay, so when we're talking end behavior, I know that that's going to be the limit as x approaches negative infinity of f of x, and the limit as x approaches infinity of f of x. Now, it just says in behavior. If it said left in behavior, or as the input values decrease without bound, then I'd only want to put one of them. I don't put both of them. All right, so let me just go ahead and fill all these in. Limit as x approaches negative infinity. This guy is g of x. Limit as x approaches infinity of g of x. And then limit is as x approaches negative infinity of h of x. The limit as x approaches infinity of h of x. Limit as x approaches negative infinity of k of x. Limit as x approaches infinity of k of x. All right. So when I look at this, I'm going to start by doing the arrows. The arrows give me my answer. So my leading coefficient's positive, right-hand side goes up. The degree is even, left-hand side is the same. These are pointing to my answers. It's infinity, infinity. On B, this is my leading term. Right-hand side is up. Degree is odd, left-hand side is opposite. So this is negative infinity, infinity. Here is my leading term. Right-hand side is down because it's negative. Degree is even, so it's the same. My answer is negative infinity, negative infinity. Leading term, so negative and odd, so it's opposite. So this is infinity and negative infinity. It's that easy. All right, last page. Determine the average rate of change of the function. Good Lord, y'all, average rate of change. Some of us still, I don't even know what's happening here, but this is just slope. And it's slope in function notation. And I know for a fact you do it in pre-AP Algebra 2 because I'm tutoring somebody in pre-AP Algebra 2. And guess what we're doing? this. And some of you act like you have never seen it before. I don't even know what's happening here. But before I even worry about what this is, I have this. So I know I need f of 2. Oh, that's not a 2. F of 2 minus f of negative 9 over 2 minus a negative 9. Then I worry about all the rest. Okay, I have to find f of 2. How do I do that? I do f of 2 and I substitute it in right here. Negative 2 squared minus 9 times 2 plus 26. So that's going to give me negative 4 minus 18 plus 26. That's negative 22 plus 26, which is 4. Then I also need f of negative 9. So negative 9 squared minus 9 times negative 9 plus 26. So negative 9 squared is 81, but I make it negative, so that's negative 81. That'll give me a positive 81 plus 26, which is 26. Now I go and substitute them in. F of 2 is 4, minus f of negative 9 is 26, over 2 minus a negative 9 is 11. So then that gives me negative 22 over 11, 11, which is negative 2. All right. Determine if the following have absolute maximum, minimum, both, or neither. Here's my leading term. So my end behavior is down, up. So that means I can't have either one. So this is neither. And f is an odd degree function. It's not necessarily an odd function, it's an odd degreed function. Here we go. Positive, it's the same. So if my end behavior is up, up, then I would have a minimum down here somewhere. So this is absolute minimum. And the reason is that G is an even degreed function with positive leading coefficient. All right, leading term here. That would be up, down. So that is in odd degree. So this is neither. H is an odd degree function. All right. Leading term. Right-hand side is down. It's even. So that means up here I'm going to have a maximum. So absolute maximum. And my reason is H is an even degree function with negative leading coefficient. All right, find all zeros, real and complex, for the following, which means I have to be able to factor accurately and efficiently. I factor out a GCF, negative 5. Oh, I can't factor out a negative 5x, right? I can just factor out a negative 5. So that leaves me with x squared minus 16. So 0 equals negative 5 times x plus 4 times x minus 4. So x equals plus or minus 4, or negative 4 and positive 4. You can do it either way. All right, so I'm going to factor here. I don't have a GCF, so I'm going to multiply. This gives me a negative 45. So I need two numbers that multiply to give me a negative 45, subtract to give me 4. So it's going to be 9 and 4. So 5x cubed plus 9x squared. Oh, wait. Oh, look at what I'm doing. I do have a GCF. I need to factor that guy out first, right? Goodness gracious, me making up stuff. Because I can't do what I was about to do. I need to factor out that x times, now I have a quadratic. I was getting way ahead of myself there, but I caught myself because I could tell what I was doing made no sense. All right, now I'm still going to get that negative 45, and my numbers are still the same. 0 equals x, and then I'd have 5x squared plus 9x minus 5x minus 9. And so now I'm going to factor it by grouping. I'm going to put in some brackets here. Out of these two, I can factor out an x. That leaves me with 5x plus 9. Out of these two, I can factor out a negative 1. Leaves me with 5x plus 9. So that means I get 0 equals x times 5x plus 9 times x minus 1, or these two could be switched around, whatever. But then you get that your x values are going to be negative 9/5, 0, and 1. Okay, it's factoring. It's factoring. All right, so out of these two here, I have 4 terms, so I can just go ahead and start with the grouping process. 0 equals, I can factor out a negative 2x. That leaves me with x squared minus 1. And then negative 8. That leaves me with, oh my God, not x squared minus 1. I'm sorry, I'm trying to hurry because I'm about to run out of time. When I factor out, I can factor out the x squared. So that leaves me with x minus 1. And then negative 8. And I caught myself because my parentheses weren't going to match. And it gives me x minus 1. So that means that 0, I could have factored out a GCF. I didn't do that either. If you do that at the beginning, it's fine. If you don't, I'm going to show you why it's fine here also. I'm not going to start over. So that equals a negative 2x squared minus 8 times x minus 1. Okay, so I realize now I should have factored out my GCF. I can factor it out of this, though. That's totally fine. So 0 equals, I'm going to factor out that negative 2, leaves me with x squared plus 4, and then x minus 1. Which, if you would have factored out the GCF first, you would have ended up with the same thing right here. So now when I go to find these, this guy doesn't give me a 0. This I can't factor anymore because there's no sum of squares. And this guy gives me a 0. So if I set x squared plus 4 equal to 0, then x squared equals negative 4, and x equals plus or minus 2i. And here, x would just give me 1. So overall, I have that x equals 1 and plus or minus 2i. That's my answer right there. Okay. All right, on this one, hopefully I have enough time to finish this. I'm running short on trying to get this done for y'all. I need to do a sign chart. Okay, it's already factored for me. That's great. And I want to know a few things, like some of them are included, some of them are not. So I'm not going to put open and closed circles here. But this guy gives me a 0. This is negative 7. This is positive 4. So negative 7, 0, and positive 4. So to pick numbers here, I can pick a negative 8. Anything I put in here is going to be squared, so that's positive no matter what. Negative 8 plus 7 is negative. Negative 8 minus 4 is negative. That's positive overall. If I pick negative 1 here, that one's positive no matter what. Then that's going to be positive, and that's going to be negative. So that's negative overall. If I pick 1 right here, that's going to be positive, and then positive, and then negative. That's negative overall. X minus 4, I'm sorry, if I pick a 5, this will be positive, positive, positive. Positive overall. All right. So now let's answer these questions. I want this to be greater than 0. So that means positive, and I'm not including my zeros. So my positive is here and here. So I'm going from negative infinity to negative 7. And then I'm starting back over at 4 and going to infinity. Because I'm not including it, I never include that, these are all open. Okay. Greater than or equal to means I'm actually including these. So this would be negative infinity to negative 7 included, and then 4 to infinity with those being included because of the zeros. All right. So now I want the function to be less than 0. That means where it's negative here and here. I'm not including the 0, so I have to do it as two separate ones. So it's negative 7 to 0. I got to skip over 0 and then go to 4. All right. Then less than or equal to, that means it's this whole thing. I get to include this 0 and these, so I don't do it as two separate ones. I can go all the way from here to here. So this is negative 7 to 4 included. And there you go. I know the last part I zoomed through, but I have to leave right after school, so I wanted to make sure I got this done. We're done.